はい、時間になりました。Okay, good evening. I'm Otani, so I will start the talk on the renewable energy. So now, 8 people. So please remember, observer is the other computer to check. Okay, so I will start. This might be a sixth lecture on introduction to renewable energy. So I'd like to talk about the fundamentals, just a fundamental in the sense of chemistry of photochemical solar energy conversion. So as you know, the lecture is here, and you will find the movie on YouTube. The link to YouTube movie link will appear in here afterwards. And also you will see your comment and question and answer from this page. So please check afterwards. And wait. So the important point is please send email in Japanese or English within 72 hours. That means 3 days later, in the evening of Monday, please send email. The address is OHTA at the CAT Hokkaido ACJP. Otani is the same name, the person who are playing baseball in the States. And the CAT, it means Institute of Catalysis, and the Hokkaido ACJP. The subject, the title of email should be RE, this is the code name of this lecture, 2021-0604, this is the date today, and the hyphen, and your student number, 8-digit. The email, the text body, the first line is the same as subject. The second line, your email address and the full name, and please put the nickname that will appear on website to show your comments and question. And next line should be what you learned in this lecture, and with comments on today's lecture. And if you have question, the next line, that is a question. And the blank line here. And I will give you several quiz in this lecture. So please write down the answer of question. And you need not to write the question itself, just write answer, input answer in the order of question. Okay, self-introduction. I'm Bunsho OHTANI. The Bunsho means in English, that is text. I don't know why my name is like text, but I like this name very good. And the Bunsho OHTANI, that is, the address is like this. And as I told you just before, the OHTANI means Bunsho OHTANI, and the CAT means Institute for Catalysis. Hokkaido AC means Hokkaido University, and JP Japan. So without knowing anything, you can send the email to me. And even if you don't know me or what I am, but you can send the email, and that is how to say, it is possible to make contact to me. So therefore, my business card is just showing the email address. That's all. Okay, then today I'd like to talk about the fundamentals of photochemical solar energy conversion. But to start this, I will talk about the fundamentals of energy conversion. Right? So then, the first question. This one. What is cell? In Japanese, denchi. In biology, the term cell means the different meaning, but the denchi in Japanese. Please interpret cell, denchi, in a sense of chemistry. Okay, so you have 2 minutes. Okay, finished? Okay, the next quiz. Hey, what kind of cells do you imagine? So there might be several types of cells. So what kind of cells do you imagine? Just write down. So I recommend to use to have a paper or something or smartphone to input those questions to make it sent to me afterwards. Okay, so then the next question. What is fuel cell? If you don't know fuel cell, please raise your hand by reaction. It's okay? Everybody knows? Okay, so what is fuel cell? In Japanese, 燃料電池. Interpret the chemistry of fuel cells, please. Okay. 今参加した人、この講義ではクイズが出てます。今1個クイズが出てます。もうすでに2個出ましたけど、クイズ出てます。後でメールで、そのクイズの答えも送ってもらわないといけないので、メモをするかどこかに、記入しておいてください。今のクエスチョン、What is fuel cell? 燃料電池。Interpret the chemistry of fuel cell. 燃料電池の科学を説明してください。回答は日本語でも英語でもどちらでも結構です。はい。Fuel cell is a kind of device producing electricity from fuel by using fuel, something like the hydrogen is used as a fuel, and introducing the fuel hydrogen into this fuel cell, this produces electricity, and that may work for driving cars. Okay, so the mechanism of fuel cell is shown here. The ordinary fuel cell, the fuel is hydrogen. The chemical to electric energy conversion happen. So chemical energy, that is hydrogen, has high chemical energy, and that is used to be converted into electricity in fuel cell. So the fuel H2 is introduced to this chamber, and here the hydrogen is separated into high proton H plus and electron, 2 protons and 2 electrons, and the protons go inside of fuel cell to go another electrode. The electron is moving through these wires to give some devices, and the oxygen in air is introduced here. So that is, air is introduced, but oxygen is used. The reacted on the surface of this electrode to give H2O. So here, proton is used to produce water from oxygen. So total reaction is hydrogen and oxygen is reacted to be water. This is the same as combustion. But in that case, in combustion, the heat and light appears. But in this case, just electricity is produced. Okay, so the next quiz. Can we reduce emission of carbon dioxide by using fuel cells? How much % of reduction is expected? Please answer. You don't have much time, just 30 minutes. If you don't know, please think, imagine. Okay. 100%, 50%, 30%, 0%. Any answer is okay. So the important point is I will not evaluate your answer. So the answer cannot be evaluated. So therefore, any answer can be. Right. So honestly speaking, the hydrogen is not so easily available. So therefore, in the ordinary system, fuel cell system, gasoline, neutral gas, methanol, or ethanol is used as the original fuel. And this fuel is converted into hydrogen by our modifier. So therefore, actually the starting point fuel is not hydrogen, that is gasoline, natural gas, methanol, and ethanol. This is because negligible amount of hydrogen in air is there. Because hydrogen is light, so therefore that is going up. So never remain on the surface of the Earth. So therefore, no hydrogen is available from air. So in the industry, hydrogen is produced in much amount, but discarded because that is very, very high cost of storage and transportation. So therefore, they just discard, just burning. So therefore, it is a bit difficult to obtain hydrogen. So therefore, hydrogen must be prepared. In ordinary sense, the modification, that is in chemistry, that is called modification. Gasoline or some hydrocarbon, CxH4y, plus some amount of water in vapor, they are converted into hydrogen and carbon dioxide. So this is the image of modifier like this. The size for the modifier or for cars, something like this in such a size. And inside of this modifier, the fuel hydrocarbons are converted into hydrogen and carbon dioxide. So in chemistry, one of the important points is the thermodynamics that says the spontaneous reaction without introducing excess energy, just the reaction happen. For example, if you ignite hydrogen, that is explode. So that is spontaneous reaction happen. And similarly, the modification of hydrocarbon into hydrogen, that is the spontaneous process because it gives energy. That is the energy of those chemicals is higher in this starting fuel. Therefore, the reaction may happen if the activation energy between these two one is lowered by using for example, catalyst. And similarly, in fuel cell, hydrogen is oxidized into water, or oxygen is reduced into water. And in this case, also the Gibbs energy difference is negative. So the H2O is the lowest energy. So therefore, this hydrogen and oxygen reaction occurs spontaneously. So everything in those processes are the negative Gibbs energy reaction, that is spontaneously occurring reaction. But in those processes, the catalyst is necessary to accelerate the reaction, even if in principle the reaction proceed, but actually the rate must be controlled by catalyst. So therefore, the catalyst is a very, very important function. So anyway, the chemical reaction of modification of fossil fuels is this reaction, as I told you, CxH4y plus 2xH2O is converted into H2 and CO2. And in fuel cell, this hydrogen is converted into water. Then, adding these two equations, the total chemical reaction, this is called stoichiometry, is this like this. So this is converted into hydrogen, water and carbon dioxide. So then the next quiz is, what is the stoichiometry of combustion of fuel in engines? So please write down the stoichiometry, chemical reaction, chemical equation of combustion of fuel in engines. Combustion means the action of oxygen, of fuel. I don't think you need much time because the answer is the same as this. So in combustion in engines, the fuel is changed like this. So therefore, in total, the reaction in fuel cell or the modifier and fuel cell is the same as the combustion. So then, next quiz is, which is better in energy efficiency, gasoline engines and fuel cell? Choose one of gasoline engine or fuel cell. Which do you like in energy efficiency sense? Okay, so if you think fuel cell is better, please raise your hand. Do you know the function of zoom? At the reaction, you can find raise your hand. Do you understand what I mean? So if you understand, okay, that's right. So if you think the fuel cell is better in efficiency, raise your hand. Okay. The important point is, so in gasoline engine, this reaction is used. So therefore, the total heat obtained by this reaction is higher than the reaction in fuel cell, because the energy of fuel is a little decreased by this modification, because this is the spontaneous reaction. So therefore, the energy is reduced. So some energy in the original fuel is lost. And therefore, only checking the heat of reaction of in fuel cell and gasoline engine, this is higher. However, the efficiency of use of heat into mechanical energy, so energy conversion, heat energy must be changed to mechanical energy. In fuel cell, first, the hydrogen, the chemical energy is changed to electricity, and the electricity is changed to mechanical energy by using electric motor. And the electric motor, the conversion efficiency is not so low. They're almost 90% or 80% or something. And also the important point is combustion at the engine, that there is a limitation of conversion efficiency in thermodynamics. The thermal engine, has the limitation of thermodynamic limitation for getting the mechanical energy, because the part of heat is used to heat up engine itself and also the exhaust gas. So therefore, the much energy is lost. Probably the total energy conversion efficiency in gasoline engine is lower than 20% only. And the fuel cell, ideally, the fuel cell has the very high conversion efficiency, like 90% in ideal. But actually, at least 70% conversion efficiency can be. So therefore, even if deleting the energy loss in modification, the total energy conversion efficiency is much more higher in fuel cell compared with gasoline engine. So therefore, this is better. So it is impossible to reduce the emission of carbon dioxide completely, but the amount of emission, carbon dioxide emission, must be much more lower, probably 30% or 35% can be. So therefore, the use of fuel cell is so much better, even if the same fuel, the fossil fuels are used. And the other important point is in gasoline engine, the temperature is very, very high. So therefore, the introduced nitrogen in introduced air is also oxidized to produce NOx. So therefore, it is necessary to remove NOx in exhaust gas. But for fuel cell, there is no need to think about this. So in this sense, if the fuel cell car can be produced in the same cost, that is so much better. But actually, it is not. So anyway, the important point is in chemical sense, what happening in fuel cell and gasoline engine is almost the same in reaction stoichiometry. But the important point is we can change, we can improve the energy conversion efficiency. So therefore, the most important point in thinking the energy conversion, that is efficiency. That is important point. So again, even if fuel cell is used, if the fuel, the original fuel is fossil fuel, the carbon dioxide must be emitted. But by changing the device, it is possible to improve the energy conversion efficiency to higher, improved. So therefore, it is possible to reduce carbon dioxide emission very much amount by using fuel cell. But the important point. So this is not directly related to this lecture, and this is just my personal idea. So this is the change of carbon dioxide. So now the concentration of carbon dioxide is so much changed, so much increased. Probably when I was in high school, that is about 300 or something. But now that is almost 400 ppm. And the temperature on the Earth, I don't know how to correct that data. So what is the average temperature on the Earth? But actually the temperature is increasing. And it seems almost synchronized. Okay, so therefore, we think that the carbon dioxide is the reason for high temperature warming, global warming. Yeah, probably okay. Probably okay. So just a reminder, this is my personal idea. So then, this is the world population in million. And so the carbon dioxide increase and the temperature rise seem to be almost synchronized to population. So I think that this might be reasonable because the number of people means the number of energy required for living. To live, it is necessary to consume energy. So without energy consumption, it is impossible. So therefore, the population is very, very important factor. So use of energy with large number of people and the number of population, the population is increasing. So therefore, the emitted heat. So anytime the energy consumption accompanied is energy consumption is accompanied by heat release. Everything releases heat. So therefore, the people use energy to live. That make the earth warm. And so there is another hypothesis. I don't know, someone say this, but the population may change temperature and carbon dioxide, of course. Therefore, the reduction of carbon dioxide might not reduce the rise of temperature. So if we keep the increase of world population, still temperature might be. So okay, so again, this is just my personal idea. So anyway, the important point, even if this is wrong, and actually that carbon dioxide emission is the true reason for temperature rise, warming, or the world population is the reason for the global warming. In any case, the improvement of energy efficiency is very, very important. So it is impossible to reduce the number of people, world population. So therefore, we should keep the number of population and the energy must be used. So therefore, the energy conversion efficiency, high energy conversion efficiency may, in both cases, the energy conversion efficiency is very, very important. So that's important. So anyway, the carbon dioxide itself is not, I think, not so important subject. So energy conversion efficiency improvement may help us. Okay, so the energy conversion, the gasoline engine car, the gasoline, that is a chemical energy, and that is converted into heat by engine. And in engine, the heat is used to change to mechanical energy. So therefore, at least one or two energy conversion processes are there in gasoline engine car. And the fuel cell car with modifier, the gasoline chemical energy is converted into, again, chemical energy, hydrogen. So a bit loss of energy by this modification. And then hydrogen is used for fuel cell to give electricity. And electricity, the electric energy is changed to mechanical energy. So at least 3 steps: modifier, chemical conversion, and chemical electric conversion in fuel cell, and electric mechanical conversion. So 3 conversion system processes. And higher efficiency if energy can be stored. So in this case, this heat cannot be stored. So therefore, it is a bit difficult to give high efficiency. Every time, in any case, the energy conversion efficiency must be below 100%. So any kind of reaction, if that is chemical reaction or the other one, they spontaneously proceed. So therefore, that means that gives the appreciable energy loss. So therefore, the highest energy must be 100%, but the efficiency cannot be 100%. So we need to carefully improve the energy conversion efficiency. And also the speed, the rate of reaction or process is very important. In chemical processes, this must be accelerated. Even if the same change gives energy to drive the overall reaction, the activation energy can be reduced by catalyst. And in fuel cell car, the modifier and fuel cell itself is almost the most important parts of those modifier and the fuel cell is catalyst. Without the aid of catalyst, they don't work. Probably you may know the news, the recent news, that Toyota they demonstrated the hydrogen engine car. So hydrogen engine car the hydrogen is used as a fuel. And if this hydrogen is prepared by modification, not in the car, the outside, the hydrogen is prepared. And this hydrogen is loaded in this car to be used as a combustion engine. So Toyota is clever. So therefore, they don't say that this is to be good for carbon dioxide, the emission reduction. So actually, it doesn't give any reduction of carbon dioxide emission. So that is much more worse because the hydrogen, the energy of hydrogen is lower than this gasoline. So therefore, the conversion efficiency is worse. So therefore, this doesn't give any good results, or even if the hydrogen used as a fuel. So in total, it must be worse than the gasoline engine car. But so therefore, the Toyota doesn't say this is good for environment. So just saying that the hydrogen, the speed, the rate of combustion is much more higher than the gasoline. So therefore, the very good racing car can be prepared by using this hydrogen engine car. So anyway, if the energy conversion efficiency is the key step, this cannot be realized. So then, if hydrogen can be prepared without using fossil fuel, that is actually no emission of carbon dioxide. Yes. And the only one possible production process of hydrogen is decomposition of water into hydrogen and oxygen, and hydrogen is used as a fuel. But this process is not spontaneous. So therefore, we need to inject electron in the system to produce hydrogen. So therefore, for example, electrolysis. Electrolysis is decomposition of water by using two electrodes applying the potential. And photolysis, so photoreaction or photocatalysis, the solid photocatalyst is used to drive photo-induced decomposition of water. Then I will tell you this story afterwards. And in that case, the electrolysis or photocatalysis or photolysis, the energy should be obtained from solar radiation. So in the electrolysis system, the solar cell should be connected to be used as an energy source. So anyway, again, to produce hydrogen from water, it is necessary to inject energy. So if energy is produced by fossil fuel, it doesn't mean anything. Okay, so the energy must be solar radiation. So therefore, the solar energy conversion is very important. In 2003, I checked the website of Honda, the automobile company in Japan, and there is the description of hydrogen hydrogen fuel cell car. And the hydrogen is supplied by using the CIGS, the new type of solar cell, photocell. And here is the roof with this CIGS photocell. And here is this electrolysis system by using the electricity produced by solar cell. The water is decomposed into hydrogen and oxygen, and hydrogen is loaded to this fuel cell car. Yes, that is 2003. Okay, so we should check the energy conversion. So gasoline engine car, the gasoline chemical energy is changed to heat and mechanical energy. And fuel cell car with modifier, the gasoline is modified to hydrogen and used, converted into electricity in fuel cell and then converted into mechanical energy by motor. And then fuel cell car with hydrogen from solar cell electrolysis. The starting energy is solar light, photo energy. So then accomplish this scheme, please. So in the final energy must be mechanical, of course. So fuel cell car with hydrogen from solar cell electrolysis. What is the energy conversion process here? Not so difficult. They already explained the energy conversion process, the combination. Hi, last 30 seconds. Again, you need not to think seriously because I will not evaluate your answer. Okay, so the photo energy, light energy is converted into electric energy by solar cell. In electrolysis cell, the electric energy is to be used to produce hydrogen, that is chemical energy. And this hydrogen is used to in fuel cell to produce electric energy. And this is changed to mechanical energy. Yes. But do you think it curious? So here's electricity. Here again, this electricity is used to produce hydrogen, but this hydrogen produces electricity. Again, is it necessary to use fuel cell? So at least this time, so 2003, there is no good battery. So lithium-ion battery is now very, very widely used, but at that time, not so much and not so good. So therefore, it is impossible to store electric energy in batteries. So therefore, they should do that. The hydrogen can be stored. So therefore, it became something like this. So if this solar light energy is converted into electric energy and stored in battery, and that battery may be good for changing to mechanical energy by using motor. So now the Honda doesn't think the original electrolysis and the fuel cell system because there is no description in website. So now the lithium-ion battery or the new type of battery may be available in future, in near future. So therefore, they need not to use fuel cell, just store electricity in battery to drive the electric car. So by using lithium-ion battery already that is commercialized. This is the prototype of electric car, but many companies already started selling the electric car, and enough capacity of lithium-ion battery is now available. So not so much different in the total driving distance. And lithium-ion battery, when that is started to be developed, there is some, how to say, the risk of explosion or the something. But now that is almost the fixed, and we can use safely that lithium-ion battery. And also now the second-hand battery, the usage of second-hand lithium-ion battery has been already started. So therefore, this might be good, but still, the many companies try to develop a new type, the better the battery to store energy. So therefore, they're using the solar cell and, for example, something like silicon solar cell, and the produced electricity is stored in battery, and the battery is used for making anything, including car. And for silicon solar cell, so there is the limitation of conversion efficiency. In total, that is not so high, about 10% or something. So not so high. When we consider the whole radiation of solar radiation, the total conversion efficiency is not so high. But actually, that is almost okay, and already many solar cells has been started to be used. But the problem is the electricity production is not constant, of course, and depending on the weather. And therefore, again, some adjustment is necessary. So, and also to produce silicon, the silicon that is Si, the silicon is produced by reduction of silica, SiO2. So no, how to say, production of silicon itself. So therefore, only silica is available. So therefore, to produce silicon, it is necessary to reduce, and it needs much energy. So therefore, to compensate the production cost and energy and resources, it is a bit difficult to use in wide use. But anyway, this is the almost established technique to produce silicon solar cell. And the research work on the other kind of solar cell, dye-sensitized solar cell, has been already made. But this is okay. So, and this is very easy, and compared with silicon solar cell, the cost for making this is much more lower, and the use of resources and energy to produce this dye-sensitized solar cell is much more low. But there are still some important points. This is wet type cell, so therefore the durability problem may. So then afterwards, a kind of solar cell, but a completely different type, perovskite type solar cell, has been developed. The first the research work is made by Japanese scientists, and in this case, they not using organic dye, but they use the perovskite type material, but that include the organic, for example, organics, something like methylamine, but this is much more stable, but and very, very high efficiency, above 25% of total solar energy conversion efficiency is the available. So now so many private companies started to make this, and some of them are already commercialized. And the solar energy, so hydroelectric power plant, that is originally solar energy, because the water, seawater, is evaporated by sunlight to give water vapor, and then that is changed to cloud, and the cloud gives rain. And this rain is running through river to sea. So therefore, originally the energy is from solar energy. So therefore, the use of the hydroelectric power is that means using the solar energy. And of course, the wind power, wind electricity, the originally solar energy, and without solar radiation, it is a bit difficult to make this. But totally, compared with the silicon solar cell or something, the efficiency, the cost performance is much more higher, but some maintenance is necessary, and scenery problem may happen. So anyway, this can be categorized into solar energy device. And the energy conversion in the various cells. So in the first question, in the first quiz, I told you what is cell, and to check almost all the type of cells. I think that all the cells are categorized into these 5 kinds mainly. And the first one is the primary cell, and in that case, the chemical energy stored in cell itself is used to be changed to electric energy, and no recharge may happen. But for secondary cell, that the rechargeable battery, once the consumed chemical is recovered by charging. So therefore, in the last part, the chemical energy is changed to electrical energy. And skip one solar cell, silicon solar cell, dye-sensitized solar cell, the photo energy is changed to chemical energy, and the chemical energy is changed to electricity. And fuel cell, as I told you in the first part of my talk, the chemical energy, hydrogen, is converted into electrical energy. So therefore, the concept of almost all the cells are convert the chemical energy into electric energy. The device to convert chemical energy into electric energy, that is the principle of cells. except for silicon solar cell. In the silicon solar cell, no chemical energy is included. Just change the photo energy into electrical energy. So therefore, this is the exception. And I don't like the name of silicon solar cell. This must be electricity producing device. So not a cell. So anyway, the conversion, energy conversion is most important, and efficiency must be considered. Okay, so then the fundamentals of photochemical energy conversion is interpreted. So then the fundamentals of photochemical energy conversion will be explained. So the next quiz. Why foods are heated in microwave oven? Interpret scientifically, please. In Japanese, denshi renji, but not the electron is moving in this oven. So what is the reason of heating of microwave oven, heating foods? Do you know? Honestly speaking, in Japan, internet search doesn't give correct answer. Almost all the website tells the wrong interpretation in scientific sense. So sorry for short time for answer. So the microwave heating, the principle is rotational excitation. Microwave from magnetron, that is oscillator, 2.45 gigahertz, 12 centimeter wavelength. That is almost same as the cellular phone. And water molecules are rotationally excited. So please note that the water molecules are rotating even without microwave irradiation. And that water molecule in ice are not fixed. So not rotating. Therefore, no absorption of microwave by ice. So therefore, it is impossible to heat up ice in microwave oven because water molecule in ice is not rotating. And rotational excitation, that is the high energy state, is created. And then this high energy state want to go back to low energy state to release energy as heat. That is translational energy, that is moving. And therefore, the energy conversion in microwave oven is electromagnetic wave. That is light or photon. Is converted into rotational energy of water, and then that is changed to translational energy, that is heat. So keyword is translational excitation and relaxation. Relaxation means release release energy from excited state. And every time the photoexcitation is important, but in at least the photoreaction proceeds through excited state. As you know, the photosynthesis by plant, of course, that is the photoreaction, and that proceeds through excited state of the organic compound in plant. And various type of excited states. Generally, we say that the electronic excitation, that is the photosynthesis or photocatalysis, as I told you later. And the vibrational excitation may have, for example, that is infrared region. The water warmed by sunlight, that is explained by the vibrational excitation. And the rotational excitation, in the microwave oven, water in food are excited in rotational mode. And the most easiest way of making excited state is photoabsorption. And in physics, the electromagnetic wave and the light is the same. So even if we cannot see infrared light or ultraviolet light, that is also called light. And the light is electromagnetic wave. That is the oscillation of magnetic field and electric field. And by going through the space, the electromagnetic wave, they change the field oscillation. And there are several beam, alpha beam, beta beam, gamma beam, X-ray, ultraviolet light, visible light, infrared light, microwave, radio wave, and electron beam. So which are electromagnetic waves or which are not electromagnetic waves among them? Please answer. So alpha beam is the nuclei of helium is moving, and beta beam is just an electron beam, and electron beam is just moving electrons. So therefore, the other ones are electromagnetic waves. And the important point is the action of those different type of electromagnetic waves are completely different. The gamma beam and the radio wave, the effect is much different. However, that is the same electromagnetic wave. Only the difference of the frequency, the shorter the wavelength, the higher the energy, and the electromagnetic wave has the same format, that is the sine wave in electric field, for example. And the speed of light is constant in vacuum. So therefore, the change of frequency means change of wavelength. That is one cycle, how much distance they proceed. So the frequency is called hertz by second. And therefore, the speed of light divided by wavelength gives the frequency. And the higher the frequency, the higher the energy, and the longer the wavelength. And the important point is light is the wave at the same time the particle, no weight, but the electromagnetic wave is wave and simultaneously particle and no weight. That means countable. It is possible to count as a photon. And the electron that has weight, but that can be at the same time wave, because this shows also the diffraction. So therefore, the electron and the electromagnetic wave is a bit similar. And in sense, they are both wave simultaneously particle. And the particle means one photon, or that is countable. And if this is the one photon, if the total energy of those photons are same, this one particle has high energy, and these are small particle, that means small lower energy, but the total energy is the same. And if this interact with material, the effect must be completely different. So therefore, total energy is not so important. The photon energy, one photon energy is important. And there is the maybe you know that this is visible light, this is ultraviolet light. The visible means we can see the light. And the boundary wavelength is about 400 nanometer, but this depends on individual. So someone may see the light of 400 nanometer, but someone doesn't see 400 nanometer light. And probably there is some violet color, but how many circles can you see? So that depends on you. So the boundary sensitivity to UV light is a bit different. So anyway, the important point is in the excitation, the photoabsorption process, such a kind of understanding is very important. That is why leaves look green. So I have no time to, so therefore I don't ask you this question, but this is due to that the solar radiation contains all light of colors, and the chlorophyll in plant, in leaves, they absorb the light of red and blue. So if all the colors, red, green, blue, the mixing 3 colors gives white color. And the starting solar light is white. And the chlorophyll absorbs red and blue. So red and blue is absorbed to remain green color. So therefore, green color is not used in leaves. So that is important. Green color is, discarded color by leaf. And here is the chlorophyll, the photoabsorption spectrum. The higher, that means the high absorption. And there are several types of chlorophyll, but actually here in red region and the blue region or violet region, there is intense absorption. And here is almost no photoabsorption. And here, for example, 500 something, that is green color. So therefore, those blue and red colors are absorbed by chlorophyll, and the green color remains to give the color, green color of leaves. And important point is even if the energy of here at, for example, 470 or 80 nanometer and 500 nanometer, they're almost the same energy of photons. But chlorophyll absorbs this light for 70 nanometer, but almost no absorption at 500 nanometer. That say the photoabsorption doesn't govern by the photon energy itself. The material absorbing light decide which color, which wavelength light is absorbed. And if this balls means the energy of photons, so there are many kinds of photons are coming to material. And this plate is the schematic image of material, and there is some holes. If the photons of energy almost the same as this hole, that is captured, but the other large or small energy photons cannot be absorbed. So therefore, that is the material decide which energy of light is absorbed. And the hole correspond to the energy gap. So for electronic energy, that is the discrete. So that there is not continuous. So therefore, the electronic energy is separated. The states are separated. So therefore, there is a gap between the filled electronic states and the unfilled electronic states. And the energy between this energy difference is absorbed. And for a bit smaller energy, the vibrational energy, for example, for water molecule, the vibration means the change of distance between two atoms and also the change of angle between three atoms. And this is also the quantized, the discrete level, and the photoabsorption in the range of infrared is observed by this vibrational excitation. And the other kind, that is the rotational excitation, as I told you, there are several electronic states, and this one electronic state there are several vibrational states, and each vibrational state has several rotational states. And therefore, the photoabsorption happens between these electronic states to give something. And once the electron excited in higher energy state, this can be transferred to the other molecules, and this is reduced. If the other molecule is the transfer electron to the vacant state, this is reduced, and this molecule is oxidized. So therefore, by using this the excited states, electronic states, the reduction or oxidation happening. So the photosynthesis in plant is also this kind of photochemical reaction, redox reaction. And then the photochemical solar energy conversion. So then by using the semiconducting material, it is known that the water can be decomposed into hydrogen and oxygen. So because, as I told you, water decomposition into hydrogen and oxygen requires energy. So this energy is provided by light energy, photo energy, and by excitation of semiconducting material to derive reduction of proton into hydrogen, and the positive hole remain by photoexcitation. This oxidized water into oxygen. So this is the principle. And if this is used as, for example, particle or suspension, this is called photocatalysis. And such kind of photochemical conversion is first reported by Professor Fujishima, very famous professor in this field. And the first paper is published in 1972 in Nature. And this tells, now this paper has been already cited more than 20,000 times. So that is a kind of a monster paper. And this is all, not abstract, this is all. All the contents are here, almost a one-page paper communication. And this tells that by using the photoirradiation, that is UV light, but by using UV radiation, the one electrode produces oxygen, the other electrode produces hydrogen. So in total, water is decomposed by photoirradiation. So this is a very good point. So this system possibly driving positive delta G gives energy reaction. So as I told you in the beginning, the only negative delta G reaction proceeds spontaneously. And in this system, the introducing energy or solar energy, photo energy, it is possible to derive a positive delta G reaction. That is, energy, chemical energy can be produced by photoirradiation. So this is very, very charming, attractive. And in photocatalysis, the electron excitation from valence band to conduction band happen. And there is energy injection here. So therefore, the total reaction, the reduction here, oxidation here, if the other kind of reaction, reduction, oxidation here, reduction here, in total, this is negative delta G, and this is positive delta G. The both negative and positive delta G gives energy change reaction can be driven by this semiconductor photoreaction. So this is so much attractive. And this negative delta G spontaneous reaction is also the applied the application of photoinduced photocatalytic reaction to this negative delta G reaction also that provide the decomposition of organic compounds or stains or microorganisms by photocatalytic reaction, for example, coated titanium oxide photocatalyst. And also the other kind of the phenomena happen by photoirradiation. So they are already commercialized. And these are all negative delta G reaction. So then the people try to convert chemical solar energy into chemical energy, that is the decomposition of water into hydrogen and oxygen. So the first paper in Japanese, that is in 1969 by Fujishima and Honda. And then several papers appears to decompose water into hydrogen and oxygen. But the important point is the starting Nature paper, there is no information on electrolytes, nothing explained. I don't know why, but there is no information about what kind of electrolyte solution is used in these two important experiments. Nobody knows. So then, so many people, so because the positive delta G reaction, energy conversion can be, so therefore, so many people were interested in reproduce this. And this is the example of reproducing paper. And the important point is this paper just reproducing the results, and they are published in Nature or PNAS. So that is, so the impact of these papers are very important. And what they clarified is at least it is necessary to give a small energy to decompose water into oxygen and hydrogen in addition to UV radiation. So the actual reaction setup needs the additional electric source or a different electrolyte solution giving the chemical potential. So therefore, for using titanium oxide, it is a bit difficult to prepare to produce hydrogen and oxygen at the same time, not in such the application of external energy. And therefore, so the other kind of material should be used to decompose water. And by 2000, there almost no paper showing the photocatalytic water decomposition using visible light, low energy light. They are mainly composed of in solar light. Only UV light is used. But in 2001, the Professor Abe, now he is working in Kyoto University, but he was working in my laboratory in Hokkaido University. And before coming to Hokkaido University, he had developed a new type of visible light photocatalysis. That is, in photosynthesis, natural photosynthesis, two kinds of light is used. So that is combined. One photoreaction system and the second photoreaction system there. And they are combined with very, very sophisticated molecular level, and the one system, photosystem 2, produces oxygen, and the photosynthesis 1, the other system, produces NADP plus that is be used as an energy source. So in total, 2 photons are necessary to drive the overall reaction, but the energy required for one step is not so much. So therefore, without using high energy light like UV light, it is possible to synthesize the energy in natural photosynthesis. So by mimicking this system, the Professor Abe developed a new system that is combined system. 2 types of photocatalyst is used to drive the overall water splitting without using UV light. So that is very, very, how to say, high impact work, and so many papers, so many research group followed this and developed a different type of photocatalyst to be used in this combination system. So this is beneficial, and still the research work is going, but actually not yet realized. They are practically applied to make hydrogen production system. And then afterwards, the Professor Domen in Tokyo University reported one-step visible light photolysis using a bit complicated system, gallium nitride zinc oxide solid solution. So I don't know why they use this kind of material, but actually this works. And this is the movie. So Domen's group provided this movie. And here is the setup. Here inside, there is the light source and the suspension of gallium nitride zinc oxide. And by irradiation, the oxygen and the hydrogen is produced. And this gas is introduced in this chamber to give bubbles. So this is a real time, not the fast wound. So actually it is possible. And now the Professor Domen is trying to the practical application of the system to produce hydrogen in large scale, but still not yet good the performance. So at least to compete with solar cell and water electrolysis system, it is necessary to make much more higher efficiency. So that is still a problem, but there is a, how to say, chance to be used. So therefore, in that case, the hydrogen is used, and the solar light is used, and the hydrogen is directly prepared, and the hydrogen can be stored. Not so easy, but not so difficult compared with electricity in battery. So then they are now trying to use this. So then the energy conversion is like this. Every time we need to think what kind of energy conversion are included in devices or systems. And the most important point is the total conversion efficiency. And of course, the device cost itself is important, but the total energy conversion efficiency is most important. And this is my personal opinion. although we are working in the field of photocatalysis to prepare hydrogen from water, but honestly speaking, the most probable way of utilize solar energy is to use silicon solar cell. This electricity is stored in battery, and then that is used in any kinds of applications. So that can be used for automobiles and also used in home and in industry and everything. And some people say that it is impossible to substitute jet plane to electric plane, but actually maybe you know that the small size airplane has been already electrolyzed. So electric plane has been already developed. And it is not completely converted into electric systems. So the part, for example, jet plane should remain. And that in total, that may reduce the total carbon dioxide emission and global warming. So therefore, we need to, again, we need to think about the total energy conversion efficiency. Thank you. So the class is over, and please send email, and I will answer if you have question, and that can be seen. And afterwards, this lecture is recorded and will be uploaded in YouTube, and the link will appear here afterwards. And please send email. Again, the email address is ohtani@CAT, and the subject should be because the older mails are categorized by using this subject. So therefore, please use this format. RE202100604 your student number. The first line of mail body is the same as subject, email address, full name, nickname, and what you learn, and the comments on today's lecture. And then if you have question, please put. And then blank one line, and one blank line, and the answer of questions. So you will see the slide PowerPoint file converted into PDF file will be here afterwards, and you can check also. And of course, you can see the YouTube movie again. So okay, so if you agree, may I ask you to turn on your video, and I'd like to have a screenshot with you. May I ask to turn on video? Thank you. Thank you. If you don't like, so you need not to turn on. Is it okay? Okay, I will take screenshot. 1, 2, 3. Yes. Oh, okay, again. 1, 2, 3. Okay. Thank you so much. So please send the email to me within 72 hours. Thank you.
Thank you, Sensei.
Thank you, Sensei.
Thank you. Bye-bye.
先生すいません、ちょっと
はい。
ありがとうございました。TA の小野です。
はい、ありがとうございます。
ありがとうございます。今日のその講義でなんか回答してほしいっていうふうにスライドであったと思うんですけど、先生にメール送るやつ。
はいはい。
あれってその質問ってこの講義中に出された質問だったらどれでも大丈夫って感じなんですか？
一応全部答えてほしいんですけ
全部ですか。
はい。
わかりました。ありがとうございます。
はい、はい、はい。よろしくお願いします。
はい、失礼します。
はい。